Almost everything in the universe is still hiding a secret. Dark matter may be holding galaxies together, the universe is expanding in ways we can't fully explain, and enormous black holes appeared surprisingly early in cosmic history. Somewhere along the way, matter gained an advantage over antimatter. Billions of stars remain silent about whether we're alone, and the beginning of time itself may be beyond our reach. And when we follow the universe all the way to its final moments, we encounter a future stranger than anything we've imagined. These are 10 mysteries that could change how you see reality. Number 1. Dark matter. Galaxies shouldn't behave the way they do. Stars at their outer edges move so quickly that the visible matter shouldn't have enough gravity to keep them from flying away. Yet the galaxies remain intact. Something invisible appears to be supplying the missing gravity, something we call dark matter. We can map its effects across the universe, but after decades of searching, we still haven't identified what it actually is. And strangely, dark matter isn't even the largest unknown in the cosmos. Number 2. Dark energy. Something else appears to dominate the universe, and instead of pulling things together, it pushes the universe apart. The universe isn't simply expanding, its expansion is accelerating. That discovery was unexpected because gravity should act against expansion, gradually slowing it down. Instead, distant galaxies are becoming separated at an ever-increasing rate. Scientists call whatever drives this acceleration dark energy, and it appears to account for roughly 70% of the universe's total energy budget. One possibility is that empty space itself contains energy. Another is that our understanding of gravity isn't complete. We don't yet have the final answer. But when scientists try to measure exactly how fast that universe is expanding, something doesn't add up. Number 3. The Hubble Tension. Imagine having two incredibly precise speedometers measuring the same car and getting different results. That's roughly the problem cosmologists face. One method measures the expansion of the relatively nearby universe using objects whose distances can be determined. Another looks back to the cosmic microwave background, the faint radiation left over from the early universe, and uses our cosmological model to predict today's expansion rate. The answers don't perfectly match. This disagreement is called the Hubble Tension. Researchers have tested measurements and searched for hidden errors, but the puzzle remains. Maybe something is wrong with our measurements. Or perhaps the universe is telling us that our model is missing something. And to find the next clue, we have to travel billions of years backward, to the universe's earliest moments. Number 4. Matter and antimatter. The early universe was incredibly hot and energetic, producing matter and antimatter together. When the two meet, they can annihilate. If the universe had created perfectly equal amounts, almost everything could have disappeared into radiation. But matter somehow gained a tiny advantage. That imbalance allowed the leftovers to become stars, planets, galaxies, and eventually us. Scientists know some processes can create differences between matter and antimatter, but the effects we understand don't fully explain the dominance of matter we see today. So somewhere in the earliest moments of the cosmos, something tipped the balance. And that tiny victory may be the reason anything exists at all. But the surviving matter didn't remain a chaotic cloud forever. It began building the universe we see today. Number 5. Supermassive black holes. Stars formed, galaxies emerged, and deep inside many of them, something enormous began growing. Deep inside many galaxies, something even more extreme appeared. Black holes millions or billions of times more massive than our sun. The problem is that astronomers have found some of these giants when the universe was still surprisingly young. A black hole can grow by consuming matter and merging with other black holes, but building billions of solar masses takes time. So how did some become enormous so early? Scientists are investigating possibilities ranging from unusually massive first black holes to the direct collapse of enormous gas clouds. But black holes aren't the only strange things coming to us from the distant universe. Sometimes our telescopes catch something that lasts for barely a few milliseconds. Number 6. Fast radio bursts. Every so often, our telescopes detect something that lasts for barely a fraction of a second, a fast radio burst. Some of these flashes travel billions of light years before reaching Earth, releasing enormous amounts of energy in milliseconds. We now know that highly magnetized neutron stars called magnetars can produce FRBs, solving part of the mystery. But researchers are still working out whether all FRBs share the same origin or whether different mechanisms create different bursts. Imagine receiving a signal that began its journey before humanity existed, crossing billions of light years before ending in a detector on Earth. And that raises a much bigger question. If the universe is capable of producing all this complexity, could something else be out there watching it too? Number 7. The Fermi Paradox. The Milky Way alone contains hundreds of billions of stars, and we now know that planets are common. The universe has also had billions of years for life to emerge and evolve. So if intelligent civilizations can arise elsewhere, why haven't we found clear evidence of one? That's the basic puzzle behind the Fermi Paradox. Maybe intelligent life is extraordinarily rare. Maybe civilizations don't survive long enough to become detectable. Maybe interstellar distances make communication nearly impossible. Or perhaps we're simply among the first. So far, there is no confirmed evidence of an extraterrestrial technological civilization. But here's the unsettling part. We don't know whether the silence means we're alone, or whether we're simply listening in the wrong way. But there's one intelligent observer we know definitely exists. Us. Number 8. Consciousness. Your brain contains billions of neurons communicating through electrical and chemical signals. We can measure brain activity and connect specific regions to memory, perception, emotion, and behavior. Yet one question remains incredibly difficult. Why does any of this produce an inner experience? Why does pain actually feel painful? Why does music sound like something? Why does the world appear from a first-person perspective at all? Scientists have proposed theories for how consciousness might emerge from brain activity, but there is no universally accepted explanation for subjective experience. The mystery is no longer billions of light years away. It's happening inside the very organ we're using to investigate the universe. And that same mind can ask a question that takes us far beyond the stars, all the way back to the beginning of time. Number 9. Before the Big Bang. As we trace cosmic expansion backward, the universe becomes hotter, denser, and more extreme. Eventually, our current theories reach a point where they can no longer reliably tell us what happened. This is where the question becomes almost impossible. What came before the Big Bang? The catch is that time itself is part of our universe's structure. If time began with the early universe, then asking what happened before may not even make sense. Other possibilities have been proposed, including inflationary and bouncing universe models, but none has been confirmed as the answer. We can see remarkably close to the beginning of cosmic history. Beyond that boundary, we're entering territory where our best physics may no longer be enough. And if the beginning of the universe is difficult to understand, there's one final direction we can look: forward. Number 10. The end of the universe. The universe is expanding, and under our standard model, that expansion continues indefinitely. Stars eventually exhaust their fuel. New stars become increasingly rare. Galaxies grow darker and more isolated. Over unimaginable stretches of time, even black holes could slowly evaporate through Hawking radiation if our current understanding is correct. The universe could eventually approach an incredibly cold, dilute state where almost nothing happens. This possible ending is called heat death or the Big Freeze. Other outcomes have been proposed, but none is certain. The universe may not end with an explosion or a final moment. It could simply fade, star by star, galaxy by galaxy, until almost nothing remains. We've uncovered some of the universe's biggest mysteries, but the deeper we look, the more questions appear. Which mystery do you think scientists will solve first? Tell us in the comments and subscribe to Brainwave for more.